Hi, in this video I will teach you about collinear vectors. Let us start with the definition. Two vectors are called collinear vectors if, very simple, one is a scalar multiple of the other one. If one is a scalar multiple of the other one. In other words, if u and v are two vectors, u and v are collinear, are collinear if and only if there exists a scalar such as c such that when you multiply u by c you get v. Or, well, I didn't say which one is u, which one, it doesn't matter. So it's if you multiply v by a constant you get u. Well, that's just algebraic definition. Let's just see an example that two vectors u 1, 2 and v -3 and -6 are collinear vectors. Why? Because if we multiply u by -3, it means that we are multiplying 1, 2 by -3. That means -3 times 1, -3 times 2, it is -3 and -6. This is vector v. We found a number. When you multiply to u, you get v. Well, I will tell you in a minute what is the general method to check collinearity of two vectors. But before that, let's check this thing geometrically. Actually, this is the reason that the naming is there. Two vectors, remember, the vectors always start from the origin. So if this is u v, two vectors are collinear if the line passing through the origin and in the direction of one of them, in this case, let's say the line passing the origin and in the direction of u is the same line which is in direction of v and passes through the origin. Well, you can see that in different ways this can go wrong. For example, u can be this and v can be this vector, and then when you're trying to see what are the lines passing through the origin in the direction of that v and u, you notice right away that these two lines are different lines. So these two vectors are not collinear. They don't have the same line, but these two are collinear. They have the same line. That's where the naming comes from. Okay, well, but how? How to check collinearity? Two vectors are given. Now you want to check if these two vectors are collinear or not. Well, you have to check two things. First, they need to have exact same zero components if they have any. So the vectors need to have same zero components if they have any. If they have any zero component, if u has zero component in the first component, v needs to have zero component in the first component. If v has in the third one, u needs to have the in the third one. But that's not all. That's just a starting point. The main thing is the second thing. The ratio of, now that you saw they have the same zero component, ignore the zero components, check the non-zero components. The non-zero components have the same ratio, meaning that u1 divided by v1, if they are non-zero, needs to be the same thing as what u2 divided by v2, and that needs to be the same thing as u3 divided by v3. If they are non-zero, then you can find those ratios, and then they need to be the same. So two things you need to check. First, they have exactly same zero components. Second, the non-zero components have the same ratio. Okay, let's do some examples. Check the collinearity of the given pairs of vectors. The first pair is 1, 2, 0 and 2, 4, negative 1. The second one is 3, 0, negative 1, and then negative 6, 0, 2. And the third one is 1, 2, and 2, 1. Okay, the two things that you have to check, you have to remember first, do they have the same zero components? Here, the first one has the third zero, but the third component of the second one is non-zero. So that right away means that first criteria fails. So the second zero component, the second vector, has non-zero third components. Well, that means that this fails, and as a result, not collinear. Okay, that's the first one. Second one, okay, second pair, you look, okay, both of the second components are 0 and there is no other 0 in these vectors. So then they have same 0 components. That's the first step, but we have to check the non-zero components ratio. Well, I don't know if it is correct, this one or not, but we have to check those one. So non-zero here is 3 the first for the first one, and -6 for the second one, and -1 for the third component of the first vector, and 2 for the 2 for the third component of. These are the ratio of the corresponding non-zero components of the vector. You see that 3 over -6 is -1 over 2, and that means that they have the same ratio. Let me write this a little bit carefully. V1 over U1 is the same thing as V3 over U3. They have the same thing, so this is also true. Then as a result, are collinear. The third pair, first thing to check, they don't have any zero components, so then the first step is, first criteria is good. The second one, however, you have the first component over the first component, second component over the second component. This is half, this is 2. These are not equal. As a result, the second criteria fails, and that means that these are not collinear. Well, these are what you have to know about the collinear vectors. First, the definition, the algebraic definition. One is the scalar multiple of the other one, and then geometrically understand what is going on. And then important thing is that learn how to check in general if the two given vectors are collinear or not.